Hey gang, welcome back to Auto 120. Now, I know we want to jump right into diagnosing wires and wiring repairs, but let's just take a moment and go over meter usage again. So the first thing that we want is a quality digital volt ohm meter, or DVOM. The analog type isn't really good enough for automotive. It doesn't refresh quickly enough, and when we get into more advanced diagnosis, it doesn't have the range of functions that we're looking for. So we're looking again for a high quality DVOM. Any of the tool trucks sell really good ones. I like Fluke as well. But do your research before you buy one, because a good one is quite expensive, but entirely worth the money that you're going to put forward. But before we get into which one to buy and how to test a wire, let's figure out how to use the DVOM in its most basic functionality. And we'll start with something that we're looking probably to do 90% of the time with a DVOM, and that's a voltage test. Figure out how many volts are in a wire, at a connector, or along a circuit. So first thing we're going to do is we're going to draw a wiring diagram so we can understand where we're putting this thing in. So this is for the voltmeter, and of course we're going to have our battery positive. Remember I said that could be anywhere 12 to 14.5 volts, doesn't really matter. We just know that whatever we're reading should match the battery kind of thing. So we're going to have a circuit, we're going to have a fuse up next, always a fuse. We go down, and in this circuit let's do a ground side switch. So we'll just put the load here, and the load is just going to be an incandescent light bulb. Let's say it's a 194 peanut bulb, or just those little tiny bulbs that we usually see in turn signal lights and stuff like that. So we'll draw a bulb that represents the element in the lens, and from there we have our switch, and of course our path to ground. So if somebody asks you to check the voltage of the circuit, we could simply take our meter, tap it in at the battery or at the end of the fuse, and either one of these we could go through the meter and to ground. Through meter to ground. And both of those, what are they going to tell us? Well, they're going to tell us not what the battery voltage is, but the difference between battery voltage and the ground path. So the voltage potential difference between battery and the ground, we'll say that the battery is, for argument's sake, 12.6, or let's just go 12 volts. For argument's sake, each one of these meters is going to display 12 volts. Doesn't matter where, 12 volts. So let's see the voltage differential between the front of the bulb and ground. What do you think that's going to be? If we look down the circuit, nothing has consumed voltage at this point. So this voltmeter should read 12 volts. Now, ideally in this circuit, let's energize the circuit, of course. There we go, circuit is energized. These meters will still all read 12 volts. With the circuit energized, the bulb is putting out light, and it is the only load in the circuit. So it should, ideally, in a series circuit, consume all of the voltage. So if we measure after the bulb, what is the difference between the ground side of the bulb and ground itself? Well, we're going to find out real quick. There's no voltage left after we've used it all in the bulb. So that's one way of using a voltmeter, just to test what voltage is at certain parts of the circuit. Ideally, or otherwise, we could check what the voltage drop across a component is. So let's test for voltage drop across the fuse first. So we put our meter here, positive lead at the most positive, negative lead at the most negative. And what are we going to see for a voltage drop across the fuse? Nothing. There is no voltage drop. So there is 0 volts of difference between the front and the back of the fuse. On this circuit here, let's test the wire going to the bulb. Put another meter in. What gets dropped across that wire? Ideally, again, 0 volts. And then finally, we're going to test across the bulb. So we put our leads in to the terminals on either side of the bulb. We hook up our meter. And for this example, it uses all of the battery energy. So we would see a 12 volt drop across this bulb. Pretty easy. So when we're using a voltmeter, you'll notice that we put it in parallel with the circuit. So voltmeter usage. Parallel with the circuit. And the circuit should be on. Oh. Wow, some spelling there. Bear with me. So the voltmeter usage, we're going to put it in parallel with the circuit, and the circuit is going to be on. The voltmeter is going to have a high internal resistance, so electricity isn't going to be able to flow freely between it, but it's going to be able to measure the potential differences from one spot in the circuit to the other. Remember, when we test anywhere here and drive it to ground, it is the same ground that the rest of the vehicle shares. So essentially what we do when we do a short ground like that is we've driven the ground all the way to there, ideally speaking. So that's a little bit of voltmeter usage. Let's make this simpler. Dumb this all down. Instead of having it look like a high school football plan, we'll make a simple circuit. Battery plus, fuse, bulb, ground. And that voltmeter should be parallel. Okay. Of course, the indicator on the meter, here's the face of the meter here. It should be set to volts, and you're going to see like this on the actual dial setting, and that's what you want. The other dial setting goes like this. That's AC voltage, and that is not generally a car thing. So we want volts DC. And of course, if you don't have an auto ranging meter, you have to make an assumption about the voltage that you're going to see in the circuit, and usually it will be less than 20 volts. So we can pick the 20 volt scale and be fairly confident that we'll be able to see the full range of voltages inside of that circuit. So that's voltmeter. Has to be in parallel, circuit should be on. It's measuring voltage differential, not actual voltage. So let's move on from here. Next up, we'll do ohm meters. And of course, that ohm meter function is part of your digital volt ohm meter. So we're going to switch our digital volt ohm meter to ohms. Inside of a circuit, we'll do the same circuit for argument's sakes. Just a fuse there. Switch and ground. So the ohm meter measures the resistance of a circuit or a component of that circuit, and that will tell us if it's within expected parameters. How much resistance can we expect to see in a component versus how much actual resistance there is. If we're measuring a circuit, the circuit must be depowered. It must be off. So if we wanted to measure this entire circuit right from here to there, we'd have to remove the battery in order to measure the entire circuit and then close the circuit. So we would close the circuit like so, put the ohm meter here. Of course, that's the Greek symbol for omega, to the beginning of the circuit. And that would test resistance throughout the entire circuit. If it's a single bulb circuit like this, it would test just that single bulb. If it was a parallel circuit with two bulbs in it, it would check the resistance of both of those bulbs. So it was 2 ohms with one bulb, it's only 1 ohm with 2 bulbs. That's how that's going to work. It's self-powered. If we try and power the circuit, the meter will not read accurately. So we cannot use an ohm meter when the circuit is powered. That's a pretty big takeaway here. So that's fine, that's the whole circuit that we've measured. What if we just want to measure the resistance of one component? What if we want to see if one of these bulbs is open? So we take our ohm meter, we remove the leads from the ground and the positive point of the circuit. There we go. Of course, power is still removed. We're working on a live circuit. We're trying to check resistance of it. So you think to yourself, well, I'll just test the resistance of one bulb. And you hook up your meter like that. And this meter right now will tell you if both those bulbs are in good condition. If they are 2 ohms apiece, it will show you that there is 1 ohm of resistance. But they should be, I just want to check this one. What's happening here is current is supplied by the ohm meter in order to gauge the resistance of the component. It sees this as a parallel circuit, so not only is it sending current through here, so coming from itself, going back into itself to gauge the resistance, but it is also sending current through anything else that is spliced into this circuit. So our readings of a single bulb are skewed. This could extend into the fuse block, into other circuits, and so on, and can really mess with our reading. So any time that we are trying to measure the resistance of something, we have to isolate it from all the other circuits. So in this case, what we would do, we would disconnect the bulbs. So that way, there we go, that way it would show us, hey, this is the resistance of only the component that we're trying to test, and not the resistance of the entire vehicle or multiple circuits or anything like that. So anytime you do a resistance check, the component that you're trying to test has to be removed from the circuit. Just like the volt test, you're going to see on your meter. There we go, there's meter again. Hello meter. Here's our display screen. We are going to have a dial. And of course, we are going to focus it on the omega sign. If you don't have an auto-ranging meter, you have to make assumptions about the internal resistance of the component that you're about to test. It can range anywhere from a few ohms to a few million ohms, depending on what the component is. Reading the surface information to figure out what you're testing before you start testing it is, of course, paramount to your success. So, pretty simple setup on the meter. Of course, we're still going to use that volt-ohm slot on the meter and a common ground. So that's pretty complex, actually. But it's simple to understand when you understand that this is supplying a little bit of power in order to measure how much resistance it has going back into it. And if we have it hooked up to multiple circuits, it will power multiple circuits. Okay, not enough to actually make the circuit operate, just enough to tell the meter, hey, this is what's going on. So, yeah, isolated component. There we go. That's a good one. That's an ohm meter. So, your digital volt ohm meter that you bought should also include one more meter function as a necessity of it. This function can damage the meter if it's not done properly, and it can damage the vehicle if it's not done properly. Where the ohm meter and the amp meter, or the ohm meter and the voltmeter, have a high internal resistance and generally don't let electricity flow through the meter in any great quantity, if you use the amp meter to measure the amount of current, there is very little internal resistance to the meter. It is letting current rush through the meter so it can count the number of electrons that are going by. So if we hook up an amp meter in the wrong way, we risk blowing the fuse in the meter, setting the meter on fire, or damaging the vehicle because we've caused a short to ground. So amp meters require your attention when you're setting them up. So let's set up an amp meter. So amp meters generally can't take more than 10 amps of current. We have to make assumptions of the circuit before we start throwing amp meters in it. For certain new cars, they're going to draw a tremendously high amount of amperage if you do something as simple as open the door. So if we're doing current draw testing on the battery or parasitic load testing, you have to be aware that if you've hooked an amp meter up in series, you may damage that meter very quickly. Again, hooking a meter up in series is part of using a meter, but doing it safely for yourself and the equipment is very, very important. So, amp meter. We're going to draw our circuit. So we have our battery positive. We have that fuse because we need a fuse. We need circuit protection. We're going to have, let's do a power side switch because that's fine. I'm going to do a bulb and ground. And then of course we close that switch and our bulb illuminates. There we go. How much current is this bulb using? Well, we can figure that out. We could use our old Ohm's law and do some calculations, or we could just measure it with an ammeter. So anywhere in a series circuit, current is going to remain the same. Okay? We can stick our ammeter anywhere in this series circuit. It has to be part of the series circuit. If we do something like that with an ammeter, that is a dead short. It's a short to ground. Ammeter goes bye-bye. You blow up the fuse, it is a short, it just goes snap. You'll either blow that fuse or the internal fuse in the ammeter. So don't hook it up in parallel. Don't hook it up in parallel. We have to hook it up in series anytime that we're using it. So, open up your circuit, replace a wire or just a connection point with your amp meter. Here we go. Here's our amp meter in the circuit. Because it's low internal resistance, electricity is going to flow through it and not be horribly affected by it in the circuit. So what we're going to see is displayed the current or amps inside of that active circuit. Now again, it can only do up to 10 amps. So a bulb, fine. Something low draw, fine. If you are going to be probing a high current circuit, it is better that you use an inductive amp clamp. And I believe you were shown inductive amp clamps in 106. But what an inductive amp clamp does is it clamps around the circuit and goes back to tell the meter what the amperage is. All it's doing is it's measuring the magnetic energy that comes off of the electrons as they move through a conductor. And we'll get into more of that as we go through the course. But sneak preview, moving electrons create a magnetic field. So over 10 amps, we're going to use an amp clamp. Under 10 amps, we can use an amp clamp or actually put your meter in line. For most of the experiments that I'll be showing you, I'm going to put our meter in line. The display is really clear. It's very easy to see what we're doing. And yeah, it works probably the best for visual recognition as far as this course goes. But what do we need to take away from this? Well, amp meter has to be in series. And the circuit is operating. Neat. So those are the three main phases of a meter that we're going to use in this course. When you see me doing experiments on the board in front of me, that's the theory that we'll be using. So what I want you to do now is, well, probably watch the next video. I'm going to show you how to test a wire from end to end, what to do and what not to do. Until you start the next video, take care. Bye now.